Imagine an AI that learns without answers. No labels, no instructions, no teacher. Just raw data and curiosity. That's the world of unsupervised learning, where machines discover patterns humans didn't even know existed. From segmenting galaxies to detecting fraud to powering recommendation systems that seem to just know you. It's all happening quietly behind the scenes. Today, you'll see how it works, why it matters, and the surprisingly simple ideas behind some of the most powerful algorithms in AI. What is unsupervised learning? Supervised learning uses labeled examples: dog, cat, horse. Unsupervised learning? It gets none of that. It only receives data, and the algorithm's mission is to group similar items, discover hidden patterns, compress information, detect anomalies, reveal structure humans never annotated. It's the mathematical equivalent of walking into a party full of strangers and naturally forming groups based on similarities without anyone telling you who's who. Why does it matter? Over 90% of real-world data is unlabeled. Businesses can't hire millions of people to manually label every transaction, video frame, medical scan, or sensor reading. Unsupervised learning allows AI to unlock insights from all this raw data without human guidance. It's how AI scales. Clustering, letting AI group similar things. The most famous family of unsupervised techniques is clustering. K-means clustering. Imagine placing K imaginary magnets across your data points. Each point sticks to its closest magnet. Then the magnets move to the center of their assigned cluster. Repeat until they stop moving. That's K-means. Practical examples. Customer segmentation. Retailers discover buying patterns: budget shoppers, frequent buyers, holiday-only customers. No labels needed. Image segmentation. AI splits an image into regions: sky, trees, buildings, based on pixel similarity. Market basket analysis. Identify natural groupings of products often purchased together. Biology. Grouping cells, proteins, or gene profiles for medical research. When K means struggles. Odd-shaped clusters. Very different cluster sizes. Sensitive to outliers. Enter more advanced algorithms. Density and hierarchical methods. DB-scan, density-based spatial clustering. This algorithm discovers clusters based on density. It excels when clusters are weird, oval, or snake-like instead of round. Real-world use. Identifying GPS trajectory patterns, network traffic groups, or construction patterns in satellite images. Hierarchical clustering. Builds a tree-like structure called a dendrogram. You can cut this tree at different heights to get different numbers of clusters. Great for understanding natural data structure, visualizing relationships, exploring data sets without guessing. K. Dimensionality reduction. Unsupervised learning also helps simplify complex data. Principal component analysis. PCA rotates your data to find the directions with the most variance, effectively compressing information. Use cases: face recognition, finance risk modeling, Gene expression data. Pre-processing before clustering. t-sne and UMAP. Perfect for visualizing high-dimensional data. They're especially popular in biology, machine learning research, and cybersecurity. Anomaly detection. Unsupervised models can spot the weird things humans might miss. Examples: fraudulent credit card activity, manufacturing defects, faulty airplane sensor readings, intrusion detection in cybersecurity, abnormal medical scans. Common algorithms: isolation forest, one-class SVM, autoencoders, unsupervised deep learning. Autoencoders compress data into a smaller representation and try to reconstruct it. If a reconstruction is poor, anomaly. Real-world case studies. Spotify and YouTube recommendations. Before supervised models ever rank content, unsupervised systems group millions of users and songs, videos, to learn similarities. Google Maps traffic patterns. Unsupervised clustering identifies typical driving behaviors: evening commutes, weekend highway spikes, rare scenic detours. Medical diagnostics. Unsupervised models found new cancer subtypes based on gene expression clustering, patterns humans had never identified. Retail and e-commerce. AI segments buyers and predicts their behavior without labels. Unsupervised learning is the quiet innovator of AI. It doesn't need answers. It doesn't need supervision. It simply discovers. And in doing so, it reveals structures in our world, behaviors, patterns, unseen relationships that humans never noticed. If supervised learning is about teaching, unsupervised learning is about exploring. And the more data we collect, the more powerful this exploration becomes. See you in the next one.